Good morning, students. Today's session is about antenna field zones. So first, let's see what is antenna field. You know that field means what? It's a place where the force is experienced. So same way, now we are going to learn about the three field regions. That is, which is called as reactive, which is called as radiating, and which is far field. So we have three different types of field zones in antenna. We have three different types of field zones in antenna. Okay, they are called as reactive near field region, radiating near field region, and far field region. See how they are terming these three concepts is based upon the distance from the antenna. See, when the distance from the antenna, see here black color, this is only an antenna. I have drawn like this. Okay, it's an antenna. And from the antenna, if the radial distance value is around 0.62 into root of L cube by lambda. See, separately I have drawn a circle here to understand. So, antenna from the center, the radial distance is about 0.62 root of L cube by lambda with this value. Okay, for example, if L value is around 8 lambda means, then that calculated some value will be here. For example, 2.2 meter. That 2.2 meter, okay, R value, for example, if it is 2.2 meter means that value will be here. Okay, so this the region associated with this is called as reactive near field region. Okay, if R value equal to 0.62 root of L cube by lambda, that value is corresponding to this region. If it is greater than that, if it is greater than this 0.62 root of L cube by lambda, and if it is within this region, okay, so there are three different radial distances. One is 0.62 root of L cube by lambda. So if it falls within this range, it is called as reactive near field. If the radial distance is 2L square by lambda, okay, 2L square by lambda, see the marked in a blue color circle and this one. So if R value equal to 2L square by lambda, that region, all this region, okay, that region is called as a radiating near field region. Okay, and then if it go beyond this, that is called as the far field region. So like that, there are three regions. Okay, so three regions are there in an antenna field. Okay, antenna field zones means what? We are going to check how the antenna radiates with respect to the position. See, we are going to check what will be the radiation pattern for this region. Likewise for the second region. Then left for the third region. So we will learn, we will understand the radiation pattern for these three regions. Okay, I'll again repeat. So what we are learning here? Antenna field zones. There are three different field regions. What are three field region? Reactive, radiating near field, and far field region. Okay, so near field and far field. What is the advantage of learning this? We are going to understand how the antenna is radiating in these different positions. If we keep it here, what will be the radiation pattern? If the antenna is kept with this distance from the origin, then what will be the radiation pattern? If the antenna is kept in a radial distance greater than this 2L square by lambda, then what will be the radiation pattern? So like that we will be learning. Okay, so this is what I've said, length of the antenna. L refers to the length. Okay, so the L is the length and R is the radial distance. Okay, so these are the parameters we are using here. Now let us see what will be the radiation pattern for these three regions. So what are the three regions I've taught you now? Reactive, radiating, far field. Okay, so reactive. Now see here the diagram. I've used different colors for you all to understand, right? Okay, different colors to understand. So black color, this is one model of radiation pattern obtained, and then I've used a green color for another radiation pattern, then blue color for another radiation pattern. Okay, now see the diagram here. Blue color radiation pattern is more or less good radiation pattern. We are able to clearly classify the lobes. Okay, we are able to classify the lobes. So that is only in the far field region. In the far field region only, we can exactly understand the radiation pattern of an antenna. Okay, what is a far field region? I've said whatever region associated with this greater than 2L square by lambda, that will contribute to the far field region. Okay, what does R refers to? It is a radial distance. Now see here how I'm going to draw this R and L. So L refers to what? The length of the antenna. Okay, and then R refers to what? The radial distance. If this R value is greater than 2L square by lambda, somewhat around like this. Okay, so with this I'm just drawing one circle. Okay, if R equal to 2L square by lambda, that radial distance one circle, greater than means that part. Okay, so I'm just drawn like this. Radial distance greater than 2L square by lambda, that region is called as far field. So here for the far field only, the radiation pattern is easily understood. Now see the radiation pattern for how it look for the radiating near field second region. Second region means what I've said, this is only second region, this is first region, and third region is beyond this. Okay, so in the second region, what will be the R value? It is equal to 2L square by lambda and greater than this 0.62. Correct? It will be greater than 0.62 root of L cube by lambda and equal to 2L square by lambda. So in the second region, the radiation pattern obtained will be, see the green color radiation pattern. Actually, it is about to form a lobe like this green color. It is about to form a lobe, but it is not clearly understood, right? So this is how it looks in the second region. Now see the first region still in a worst condition. You cannot understand the pattern at all. See the black color one, shapeless diagram I've drawn. Okay, somewhat it looks like this. So from this we understood for a far field region only, the radiation pattern can be easily obtained. Okay, for the far field region only, the radiation pattern can be obtained. Okay, so what we have learned so far, radiation field zones, 3 different antenna field zones are there. They are reactive field, radiating near field, and far field. Reactive near field, it contribute to the region for R equal to 0.62 root of L cube by lambda. And second region is R is equal to 2L square by lambda. Then the third region is greater than 2L square by lambda. And we have saw the radiation pattern. For far field, it is good to understand the lobes and all clearly understood. For the second one, little bit the lobes are about to start, but it is not framed properly, and first region the radiation pattern is worst. Okay, we cannot classify the lobes and all. This is what we have understood. Now let's see the properties of the 3 regions. So first region, as I said, it is a region immediately surrounding the antenna wherein reactive field will exist. Okay, so this is the first region. I have given the properties here. So what is the first region? Immediately surrounding the antenna where the reactive field will exist. Okay, so this is the first region. That's why the name reactive near field region. And what is the R value here? It will be less than equal to 0.62 root of L cube by lambda. Okay, and one important case here is, now see this antenna length value. Now what happens if a short dipole is used? Okay, if a short dipole is used means then the R value should be lesser than lambda by 2 pi. Okay, this is another very important property of this region. If the length of the antenna, it is short dipole antenna means, then what should be the radial distance we have to use? Lesser than lambda by 2 pi. Okay, and the another one general property is, see what will happen here in this reactive near field is, the object within this region, no, it will couple with the antenna. So that's why it causes the distortion like this black color diagram. Okay, the object within this region, what will happen? It will couple with this antenna and immediately it will arise a distortion. So that's what the radiation pattern is not marked here clearly in the first region. So that's all the first parameters of the antenna field zone. Let's see the second properties. What are the second properties? In the radiating near field, as I said previously, it is in between first layer and the third layer, correct? The second is what? In between first and the third. And then the distance will be what? It should be within 0.62 root of L cube by lambda to 2L square by lambda. And this is also called as transition region. Okay, it is also called as transition region. It's because you see the radiation pattern, it started to distinguish the lobes. It started to distinguish, but not clearly it comes. So from here, there is starting to radiation. Okay, starting to radiate. So that's why this is termed as transition region. Okay, and then the antenna pattern is taking shape but not truly formed. Correct? No, it started to take the shape. See the green color diagram I have drawn here. It started the lobes but not in a full-fledged. And here the electric and magnetic are not orthogonal. Only when they are orthogonal, the radiation will take place and the lobes and all will arise. So here the E and H fields are not orthogonal. And finally is the third region. The third region is what? What is the third region? Third region is a far field region. So as I said here in far field region, the region where the angular field distribution is independent from the distance. Okay, the field is independent of the distance. So what will be the radial distance here? It will be greater than 2L square by lambda. So there is no bounded at all. Okay, it is whatever value greater than this range are greater than 2L square by lambda, those regions corresponds to the far field, and here the wavefront will become planar. That's why the radiation pattern, this electric and magnetic are orthogonal and the radiation pattern will exist. Okay, so that's what we have learnt in today's session. 3 regions: near field radiating, near field reactive and far field regions. Okay, so in the first region radiation pattern will not be there. Second region it will start to radiate, that's why it is called as a transition region. And third one, it is called as what? Far field region, where the radiation will occur. Okay, so that's all in today's session.